Now let us try to implement the copy constructor program. Okay. So as explained in the video lecture, let us create a class dummy here, and this class contains two data members which are integers, int a and int b, and the third data member is a pointer. Okay. And in the public section, let's have a constructor dummy which takes three parameters, int x, int y, int z, where a is equal to x, b equals y, and p equals new int. So memory will be allocated for an integer, and this memory is not the part of this object, but p is pointing to this memory, and the value at this memory is equal to set. Okay, and this is our constructor. Let us also create the destructor dummy. Here delete the memory, whatever block of memory is allocated, pointed to by p. Okay, and in the main function, let us create an object of dummy d1 and put the values 10, 20 and 30 here. Okay, and let us create another object d2 where d2 is equal to d1. Okay, and at the end return 0. So here we have created no copy constructor, so the default copy constructor will be called. And what the default copy constructor will do? It will do a member wise copy, means whatever the values are there in the members of d1, the same values will be copied to members of d2. It means p of d1 and p of d2 both will point to the same block of memory. Okay. Before running this, for the time being, let us comment out this destructor. Okay, and now let us try to run this program. There is problem. Expected nested name specified before namespace. Sorry, there is a mistake, spelling mistake. Okay. No matching function called to dummy. Okay, so here we have created a parameterized constructor. Okay, this dummy is a parameterized constructor. So what happens in C++? Whenever you create any constructor, whether it is parameterized constructor or any other constructor, the compiler will not create its own default constructor. So this call will not execute because this is expecting a default constructor. But we have created our own constructor. That is why the compiler has not created any default constructor. Now let us create the default constructor for it. Dummy, and okay. So it is giving us no output, but it is running. Now let us check the values of all the data members. So let us write a display function cout a is equal to a emdl cout b is equal to, this is small b, and the third member is pointer p. The value at p is equal to star p. Okay, and also try to print the address which is there in p. Okay, p is equal to p EMBL. So star p means the value stored at the address to which p is pointing, and just p means the address to which p is pointing. Okay, and let us make a call to d1 dot display. Let us print a message here. D1's data members. Okay, and here we display D2's data members. Okay, and D2 dot display. Now we are ready to run it. There is an error. Expected semicolon. Okay. So D1's data members are A equal to 10, B equal to 20. The value pointed by P is 30 and the address of that location is E98. Okay. And D2's data members, because this is a member wise copy, it will be exactly same. 10, 20, 30, 10, 20, 30 and E98. So here we now have confirmed that P in both D1 and D2, although they are different. This is P of D1 and this is P of D2. But still they are pointing to the same memory location. Okay. And now let us uncomment this destructor also. Okay, so the same memory location will be destroyed twice. Okay, let us print some statement in this constructor. Destructing. Okay. Now let's run it. Semicolon is expected. Okay. So the same memory location is being destroyed twice. Okay. So we do not want this. We want that the P of D1 and P of D2 both should have their own memory locations to which they are pointing. Okay. Only then the programs will not have the interdependencies. Okay, because each object is intended to have its own space. Okay, but when we are using the default copy constructor, then we are not able to achieve this in case of external memory resource. So new external memory resource is not being allocated. All the pointers are sharing the same memory resource. So what we want is each pointer should have its own memory resource. That is, we want to make a deep copy. For that, we need to create our own copy constructor. Okay. So now let us create our own copy constructor. So when we have created our own copy constructor, the default copy constructor will not be used. Okay. So dummy, and let us write here dummy and ampersand d. Remember that you have to pass the object always by reference. Okay, because if you are passing by copy, then what will happen? What will happen is that you are doing d2 is equal to d1, or you can say that d2 d1. Okay, so d1 will be passed as the argument. Okay, so value of d1 will be passed, and that value will be copied here. Okay, d equal to d1. So this is a formal parameter, and it will be equal to d1. Okay, so now what is this? This is again a copy of one constructor, copy of one object to the other object. Okay, so in order to do this, the compiler will again call the copy constructor. Okay, so again copy constructor will be called, and again copying of formal parameters will happen, and this will keep on happening, and this will result in an recursion. Okay, so here recursion means you are doing the same thing again and again. Here d2 equal to d1, and here d equal to d1, and here in order to copy this, you create another copy constructor, and so on. So this will result in unending program. Okay, so in order to avoid that, the C++ has made it mandatory to pass the argument to the copy constructor by reference. You cannot pass it by value. If you try to do this, you will get an error. Okay, so here is the error. You probably meant dummy const ampersand, const dummy ampersand. Okay, so you have to pass it by reference. Okay, now what will happen? Now d is referring to the same object as d1, so both of them are referring to the same object. Okay, and another thing is that you have to write const here. The purpose of const is that the original object is not modified. Okay, so you are passing a constant object. It means whatever you are passing, it will not be modified in this constructor. It will remain intact. Okay, so now let us write the copy constructor, the body of this copy constructor. So a is equal to d dot a. Okay, b is equal to d dot b. It is also okay. Then if I write p equal to d dot p, then what is this? This is a shallow copy. Why? Because here the p of d2 is same as p of d1. Okay, so they will point to the same memory location. Okay, still we are doing the shallow copy. Although we have created our own copy constructor, even then we are doing a shallow copy. In order to confirm this statement, let us run this. So D1's data members are 10, 20, 30, and E98 is the address of the shared memory location. So it is same in both the objects. So we are doing the shallow copy. And how to make it deep copy? Deep copy means whatever things are there in object D1, all those things must be there in D2. Okay, so D1 has A, B and P. D2 is also having A, B and P. But D1 has also an external memory resource. So we have to create an external memory resource. So instead of writing P is equal to D dot P, write P is equal to new int. So now we have created a external memory resource, and now we have created a new integer. So P is pointing to this integer, and the value at this integer is the same as the value in P of object D. Okay, so write asterisk here. So these are D1's data members: A 10, 20, 30, E98. So still we are getting the same address in both D1 and D2. So they are referring to the same external memory resource. I think there is a problem here. Let us check whether the copy constructor is called or not. So cout in the copy constructor. Okay, so let's run it. See, the copy constructor is not being called. So what must be the problem? I think the problem is here. The initialization will happen at the same time when we are creating the object. Let's remove this statement. So dummy D2 is equal to D1. Let's run it. So now the copy constructor is being called, and yes, now P of D1 is pointing to E98 and P of D2 is pointing to EA8. So both of them are pointing to different locations.